Yeah, hi. Today, let me walk you through a short series on Git. It's a version control system. Now, what's version control? Let's understand with the flow. But it's beyond our save and save as button. See, when we make some changes to the file or an application, we save them, right? Or sometimes we save the versions also by naming it as name 1, name 2, or final 1, etc. So, certainly, the Git, which we are going to discuss, it's a version control system. It's beyond our save and save as. This notion of version control, we have a limited version on our Microsoft Word also. Sometimes on Microsoft Word, we see these options, right? Restore versions, recover them, or compare the changes. We have these options, but it is limited to that application and limited to the PC which we are working on, or the station which is localized onto which we are working on. We have this option also on Google Docs. If you go to file, you can see the version history, so you can view the changes and restore the older versions. So these limited editions of version control fail. I'll give you a situation now. So there is a large collaboration needed. Say there is a project going on, say website development. So there are around 1,000 files are there, and 10 developers are working on the project. Some on front end, back end, DevOps team, testing, etc. And we need 2 years of project history. Now our limited version controls of this Microsoft Word and Google Doc, they fail because we cannot track who has changed and what has changed, and can we restore the old versions. So our answer is no, we can't restore the older versions. So in situations like this, we will naturally think of a system, a software which tracks all the changes. So here for this example, I want 2 years data. So I want one software which tracks all the changes that has happened to the project file since 2 years. And there are 10 developers here. All 10 developers can work simultaneously, parallelly, without collision. I mean to say, one developer's work or updation shouldn't override the other developer's work. So there should be a safe collaboration and a track of the project history. That's what we want in this scenario. So with this scenario in mind of keeping track of all the modifications that has happened to our project and a safe collaboration platform, we feel okay, such version control is needed only for a software developer. Why not during our BE project? See, usually we have a batch of 2, 3 or 4 during our engineering projects. Say a student A working on documentation, B on circuit design and Python code and presentation. Now each stage, all these stages, we will have changes from starting to the end of the project. We would have changed so much. Now if we can use the platform of version control, of course Git, it is free and it is open source, so anybody can access. Now if I access Git for my final year engineering project, now I can keep track of all the changes and documentation made. Circuit design also, I can have 100 circuit finalized for my project, or coding, all the changes tracked, or presentation, the final one. I don't know, maybe say while coding or while deciding on the circuit, a circuit which I had designed 2 weeks before may be working fine for me. So how do I restore? So there is a platform which helps me to track all the changes which has happened through the project till now. And it is allowing all 4 of us to work simultaneously, because basically we are talking about Git, a version control system which is not bothered of what is inside the file. What is inside? It could be documentation, it could be a sketch, a circuit design, or it could be a code, a Python code, or a presentation, PPT presentation. So it is not bothered. It only tracks the changes and allows all these 4 to work simultaneously. It allows all the 4 to work simultaneously, or 40 people or 400 people, all to work simultaneously without collision. So here comes our Git. It's a distributed version control system. Distributed in the sense it allows a distribution of work. So it allows multiple collaborators to work on the same project, and that's also called branching. So many people can work safely and parallelly on the same project. And version control stands for the way it keeps track of full history of the project. So it keeps track of full project history, every change ever made. Offline work. See, what happens is Git is distributed in the sense there is central server. That means there is a repository, central repository or a main repository, and there is a local repository. That means each of the collaborator, say there is developer A, B, C, each one will have a repository. So he can make the changes on his local repository, and eventually he can push the changes to the main repository. So there is no dependency on the central server or all the time, so offline work may go on. So the developer is not on internet, still the work can go on. Scaling is an important aspect of Git. So it can scale from solo to enterprise level. The fact is, Git has nothing to do with what is inside, say whether it is a text file, HTML file, CSS, whatever it is. So it doesn't worry, it doesn't care what is inside our file. It only keeps track of every change ever made. So it is like snapshot based. So whatever changes you make to that file, it will take a photo and keep the modifications, keep track of all modifications made. So in this sense, if we see here, the scaling can go from solo to enterprise, in the sense if the project has 5 people and the same project expands. So now I have 1,000 people working on the same project. The Git can expand, or we can extend Git. It can scale itself from solo to an enterprise level. So we see Git being used by the students, hobby practitioners, project enthusiasts, and an enterprise level, a large enterprise level systems as well. So coming to the types of version control system, we have local, we have centralized, and we have local, we have centralized, and we have distributed version control. As the name itself says, it is local version control. I mean to say, the version control or the tracking of modifications what we have made to our project or the repository, they are on the local system only. That means on my personal computer or a laptop itself. So there is no collaboration here. So in this, there is no collaboration. So there is no collaboration here. When it comes to centralized version control system, see, this operates as there is a central server, and this central server maintains a central repository. So there is a central repository here. This repository allows collaborations remotely with multiple collaborators. Say we will call them as developers. Say they are working on the same project. Say there are 3 developers, A, B and C. They are working on the same project. Now this developer A, B and C, they are able to make some changes into this central repository. Now there is version control, there is collaboration also, but there is one problem here. The glitch is, see, if the server fails, or if there is a network loss, then these people cannot work. These ABC developers, they can't work on the project. Or if there is a server crash, so there is no backup. So there is a central server dependency here. Although the centralized version control system allows multiple people to collaborate and work, meanwhile maintaining the version, there is a central dependency here. The next is a distributed version control. This distributed version control, it overcomes this central dependency. The structure looks something like this. So there is a central server which maintains a repo. Usually we call it as a remote repository. So there is a remote repository, and followed by there are multiple collaborators. So we call them as A, B, C, developer A, B, C. Now what happens initially, these developers A, B, C, they will clone the remote repository. So each one of them will maintain a local repository. So A has a local repository, B has a local repository, and C also maintains a local repository. Now even at offline, there is no central dependency on this remote repository. There is no, if there is a network loss, or if the server slows down, so there is no central dependency here. These people A, B, C shall continue and do modifications on their local repository. So C, A, B and C, they will do changes on their local repository, and eventually they will push those changes to, this is called push those changes into central repository. Also they can pull those changes from this central repository. So there is push, there is pull. They can push the changes eventually, and they can pull the modifications from the central repository. So there is collaboration happening, and the work is distributed parallelly, safe, and collaboration is there, and there is no central dependency. That means this developer ABC can work offline as well. Now, where is our Git operates? Where does our Git operate here? Git operates at this point. So Git manages all the modifications that ABC they are modifying on their local repositories. So here is my Git. So Git is a software on my local system. So ABC are making the modifications onto their local repositories, and Git tracks all the changes now. Now who does this process? Now who will host all this on the cloud? So that is GitHub. So GitHub is a website. So we can think GitHub is a website which hosts what? Which hosts Git repository. It hosts Git repositories. It hosts Git repos. So now we have seen in the earlier video that developer A, B, C, they are working parallelly. So this developer A or developer 1, this person is making some changes onto the file, and this person also is making some changes onto the file, and this person is making some changes. Now all of them can push their changes. This is called push their changes onto a repository which is called remote repository. They can push those changes onto the remote repository, and they can pull those changes from the remote repository and continue their work offline. So Git allows multiple people to collaborate, work simultaneously, meanwhile maintaining all the track record and allowing all the developers to work offline. So GitHub is a cloud platform which hosts all these Git repositories. Okay, so what is the future of future workflow look like? So I need not to talk it as a future workflow. It is happening now, as we have understood that Git can scale from solo to enterprise. It can scale from a small degree level project to enterprise level project deployment. So the future workflow, it is not future workflow, it is the workflow which is happening. So how is it happening? It is happening. It's happening from solo to enterprise levels because it is free and open source. So we need not to pay for this Git software. It is free and open source because its source code is open. We can do modifications to the source code. It's an open source software. Many startups, enterprises, research, they are using, because it is open source, they are using it. It's a secure and synchronized software to manage our project and track all the modifications what we have made, what we are making to our project, and track the changes, follow up from the day we start with the project until the deployment, secure, safe and hassle free.